forces in a rotating frame. We found the relationship that relates an arbitrary vector, q, its rate of change in inertial frame S0 to its rate of change in the rotating frame S. We proceed with writing Newton's second law, which of course we have to write as the second derivative of position with respect to inertial frame as given by the force. Our task is to rewrite Newton's second law in terms of rotating non-inertial frame S. Turns out all we need to do is to apply the expression we found that relates the rate of change of arbitrary vector twice. In other words, for the rate of change of position with respect to inertial frame S0, we write as the rate of change of position with respect to rotating frame plus omega cross vector r. Next, we proceed with writing the second derivative of position with respect to time relative to inertial frame S0 as, and here we call the new vector q to be equal to the first derivative of position with respect to time, and thus we get d dt with respect to frame S of this newly found vector dr dt relative to frame S plus omega cross r. That is the first term of the expression above, plus the second term, which is simply omega cross the entire expression dr dt relative to coordinate system S plus omega cross r. Now we'll use notation that d dt relative to coordinate system S we will define as a dot operator, and we will use the fact that omega is a constant vector, so we can simplify the expression above, and we will find that second time derivative of r with respect to time in inertial coordinate system S0 is simply given by r double dot plus we have two terms, omega cross velocity r dot plus, and the last term gives us omega cross vector omega cross r. And of course all of this is equal to the force divided by mass of the body. So we have found the equation of motion relative to rotating coordinate system m times acceleration as measured in the rotating coordinate system S is given by the force plus, and here we have two terms. In order to absorb the minus sign, we will switch the order of the cross product. We'll have 2m velocity r dot cross omega plus mass, and then vector omega cross r cross omega. We recognize these terms as the force plus two fictitious forces The first force will be Coriolis force, and the second term will be centrifugal force.